Now, in this particular sum, we have been given a total of two substances. The first substance is sodium chloride, and what am I supposed to do? I am supposed to find out the mass of exactly 0.2 moles of sodium chloride. Let's begin. The sum is very easy, and we have a formula to help us out as well. Now, as far as the sum is considered, understand, and we know this fact, the number of moles of any substance given by the value small n is nothing but the mass of that particular substance in grams divided by the molecular mass of that particular substance. Keeping this formula in mind, this particular sum is child's play. It can be easily solved. Let's begin. Now, what is given to us? Given to us is that we have sodium chloride and we need 0.2 moles of sodium chloride. That is something which is given to us. What do we need over here? We need the mass of sodium chloride, which will exactly give me 0.2 moles of sodium chloride. The first thing that you must do is calculate the molecular mass of sodium chloride. How will you do it? It's very simple. So, as far as the molecular mass of sodium chloride is considered, I need an atom of sodium which has a mass of 23 and I need an atom of chlorine which has a mass of 35.5. So, let's begin. You take the atomic mass of sodium, multiply by 1. You take the atomic mass of chlorine, multiply by 1. Substitute the values. I already told you, 23 to the left, 35.5 to the right. Let's begin. So, there we have it, 23 into 1 which is 23, 35.5 into 1 which is 35.5. Let's add up these two particular values together. I get my total answer over here as exactly 58.5 grams of sodium chloride is 1 mole of sodium chloride. That is something that we must remember because we will be substituting this value in the next part of this particular sum. Let's continue. Okay. So, now back to the problem at hand. According to the formula, the number of moles in a given amount of sodium chloride, what is it? What is the numerator? The mass of sodium chloride in grams divided by the molecular mass of sodium chloride. Now, think about this. How many moles of sodium chloride do I need? In the question, read it. Perfect. I need 0.2 moles of sodium chloride. Great. Do I know the mass of NaCl in grams? No, I need to calculate that. But do I know the molecular mass of sodium chloride? Yes, I know. What is that? 58.5. So, now to find out, 58.5 should be taken onto that other side and obviously those two figures will get multiplied. Therefore, the mass of sodium chloride in grams that will be required is 0.2 into 58.5, and how much is that? That is going to give me my answer, 117 grams. Is that my answer? Yes. Let's write it down. So, I can say that the mass of sodium chloride in gram which is needed is 117 grams, and since that is the answer that I require, let me write it down once again for you and put it up in a box at the same time, right? Now, if you've understood that, the next particular part is going to be very simple for you because we're going to do something very similar, right? Just we're going to change the compound. Who's the next compound? Magnesium oxide. Now, formula remains the same. Number of moles of a particular substance is equal to mass of the substance in gram divided by the molecular mass of that particular substance. Let's begin. Given number of moles of magnesium oxide that you require, we know we need 0.2 moles of magnesium oxide. To find the mass of magnesium oxide, which will give me 0.2 moles of magnesium oxide, first thing, what should you do? Perfect. We should calculate the molecular mass of magnesium oxide. When you calculate the molecular mass of magnesium oxide, I have a single atom of magnesium and I have a single atom of oxygen as well. So, what are we going to do? Take the atomic mass of magnesium, multiply by 1. Take the atomic mass of oxygen, multiply by 1. Substitute the values. For magnesium it's 24, for oxygen it's 16. So, I have 24 into 1 plus 16 into 1, 24 plus 16, which gives me the total value as, wonderful, it is going to give me exactly 40 grams of magnesium. 40 grams of magnesium is 1 mole of magnesium. Keep that information in mind. We'll be needing it for the next part of this particular sum. Let's continue. Okay. So, now according to the formula which has been given over here, the number of moles present in magnesium oxide represented by the value N should be the mass of the substance in grams that we need to calculate upon the molecular mass of MgO that we just calculated. So, how many moles do we need? We need 0.2. We need the mass in that. So, the numerator value needs to be calculated, but denominator is something that we have already done, 40. This 40 should be taken onto the other side. So, 40 into 0.2, that is going to give me my answer. Any guesses do we have? Perfect. It is going to be exactly what? It is going to be 8 grams of magnesium oxide. Is that my answer? Yes. Should I write it down as a final statement? Yes. When you put it as a final statement, mass of 0.2 moles of magnesium oxide is 8 grams. That's my answer. That's my correct answer. Let's box it up. And that, my dear child, is how you calculate the number of grams required for a particular amount of mole of a particular substance.